So let's take a look at D. D has us looking at x plus 1 times x minus 7 equals 1. So when I look at this one, I think, oh, they've already factored it for me. But oops, someone factored it too early. They jumped the gun. Why am I saying that? It's because the right-hand side is not a 0, it's a 1. So they might, whoever did this or set this up, did the right thing, they just did it too early. So I kind of have to undo all the hard work they did. So I need to actually FOIL out what I have. So I need to multiply out the x plus 1 and the x minus 7. Let's FOIL here. So the x times the x will get you x squared. Then the x times the negative 7 will get you negative 7x. And the 1 times the x will get you a 1x. And the 1 times the negative 7 gets you negative 7. And we still have that this equals negative 1 equals positive 1 for at least now. But we would want it to equal 0. So we can move that 1 over by subtracting a 1 on both sides. And let's see where we're at now. That gives us an x squared and now a 0 on the other side. Now I can combine my like terms. Let's see what I have that are like terms. I have a negative 7x and a positive 1x. When added up, that will give me a negative 6x. I also have a negative 7 and a negative 1, which will now give me negative 8. And again, this will not factor. But if it doesn't factor, I'm not stuck. I just have to use my quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, we don't see a number out in front of the x squared, but it's a hidden 1, and that's what our a will be. Our a will be the number that's out in front of the x squared. That's a 1. Our b will be whatever's in front of the x, which is a negative 6. That's our b. And our last piece, the negative 8, is going to be our c. So let's go ahead and plug all those into our quadratic formula. So first of all, negative b. Well, b is already negative, so that's going to turn our negative b into actually a positive 6. Plus or minus the square root of, again, we're plugging in b, which is negative 6. But you're squaring it, which will give you a positive 36. Minus your 4 times, let's see, your a is next. Your a we already said was 1. And then times your c, which we already said was negative 8. And let's see what happens if we continue right along. Past this is on the bottom we will have our 2 times our a, and let's see, our 2 times our a, but our a is 1. So on the top we have a negative 6 plus or minus, and on the bottom we have a 2 times 1, which we can go ahead and say is just the number 2. Now we need to work with what's inside of the square root. We know we've got a 36 inside there. The question is what happens with the rest of this. The 4 times 1 times 8. Well, 4 times 1 times 8 is a 32. Notice though, a negative times a negative will turn into a plus 32. So let's see what happens here. We get a negative 6 plus or minus the square root of, well, what is, let's see, 36 and 32 when we add that up. What's going to be inside of my square root? Well, 36 plus 32 will give us 68. And again, this is all over 2. Your only question at this point should be whether or not that 68 can be broken down into something we can take the square root of. And you can. 68 is 4 times 17. So what that does is that lets us rewrite that square root by taking the square root of the 4, and that will come out as a 2. The 17, however, is prime, and we can't take the square root of it, can't break it down, so we're stuck with that square root of 17. But notice, now the -6, the 2, and the 2 are all divisible by 2, so let's reduce it by dividing out a 2 from the top and the bottom. That will give us -3 plus or minus the square root of 17 all over 1. Remember, if there's a 1 on the denominator, I do not have to write it. So this gives me two answers, -3 plus the square root of 17 and -3 minus the square root of 17. Those are your two real numbered irrational solutions. Let's look at our two last problems.